all in it, like maybe 15 milliliters of methanol. Okay? And what I'm going to do is I'm going to heat it up so this gets filled with methanol vapor.
Are you going to plug the top?
No, good question. I'm not going to plug the top, but I'm going to try to make this mostly methanol vapor. Because I know that methanol vapor will combust faster than liquid methanol. Okay? And I'm going to divide the front and back of the flask with this divider. See the divider? And then the question is why? That's another story. You got to figure that out. Okay? So I'm going to heat this up. Okay? And turn this on. Okay? And while that's heating, what I'm going to do, I have a very expensive piece of metal here. This cost about $200 right there. It's more expensive than gold.
$200 right there?
That little piece there. That's called platinum.
Oh, it's platinum.
Okay? It's a piece of platinum. Thick piece of platinum. So if you made a ring out of that, boy, that would be pretty expensive. And platinum is a great catalyst. Okay? Most transition metals are pretty good catalysts because for metals, they have relatively high electronegativity. So they have the ability to draw electrons on the surface. So what we're going to do is, right now it's dirty, touch the table, so I'm going to clean that. To clean it, I'm going to put it into this butane flame. I'm going to hang it on this hanger right here. Right? Make sure this is heating. More. Check that up a little bit. Okay, and what I'm going to do is I'm going to clean the platinum. So how am I cleaning the platinum? I'm burning any oil that's on it, making sure that there's nothing on the platinum except for platinum. Now there's always going to be a little bit of oxygen attached to the surface of the platinum, but platinum doesn't like to react. That's why it's so expensive. Okay, so I'm guaranteeing that the platinum's clean. Yeah. Now metals don't glow like that until you get close to 1,000 degrees. So it's close to 700 degrees. Okay, so I'm going to shut this off, and I can guarantee you that this is clean. All right? This might not work. We might have to refilm this, but I'm going to put some. I'm going to put this over here, and I'm going to put the platinum in. Making sure that the metal doesn't touch. All right? I need you to shut the lights off in the front. Pay attention to the platinum. Oh, I forgot. I gotta keep filming it, man. Don't get close. Okay? If you look at the platinum on the film, okay, back out a little bit. You're too close. Okay? You'll notice that the platinum glows before it explodes. See that? And produces. So you start glowing like that?
It's gonna explode again?
Yeah, don't get nervous.
Let me back up. I'm gonna
ruin my tape, dude. Right? It starts to glow. Right? And when it glows really, really bright, all of a sudden you get the explosion. What's happening is the methanol is touching the surface of the platinum and combining with the oxygen inside the flask. And when you get the right proportion on the surface of the platinum, you'll get the explosion. Okay, now typically it usually goes faster than that. I didn't warm up the methanol as much as I should have. But
that was almost as funny as when you fell off the chair.
We're gonna watch that.
We are. It's not gonna blow up again now. Because I didn't make the methanol hot enough. Because there's not enough vapors in here. It's not warm enough. So what's happening, it's getting on the surface, but there's not enough methanol oxygen to get the explosion. Because in order to have an explosion, you got to have the right ratio.
Put it back on the heater.
Okay, push the stop on you. Well, I may never ask you to do a filming again. It's not glowing, is it?
No.
You sure? Here it comes. Here he comes. Right?
Yeah, you can
It's
see the
magical. Magical. It'll be great when I put this all together. I'll remember Master Cola forever. I'll have the scene of him falling on the ground almost. That's gonna be the best. Yeah?
That was almost like
It's pretty loud.
does it die down over like
If the methanol cools down, it will stop.
under someone's chair?
We just recorded what you said, Al Callahan. So when we find that you do, that's pretty loud. See that? So what the divider is doing is allow for the re-explosion every time. Because if you didn't have the divider, the cool oxygen gas wouldn't be able to get to the platinum, and it won't keep exploding. But I have to tell you, the explosions are pretty loud, huh? It's pretty cool. See, it was cool that I put it in without heating it the second time to prove that it is the catalyst that's doing. It's not the heat from the cleaning of the. It's the anticipation that's scary. It's always the anticipation. I'm gonna stop.